both of these left and right side should be equal and it should give me the value 8, but that's not the case. Okay, so why? Because we saw that we have overwritten the variable y here by using this particular expression. So we will use the value y here rather than just assigning the variable the value y to this particular variable on the left side. So this y goes here, the x goes here, a goes here. MATLAB performs its computation. It finds the answer for these expressions and gives the answer with this whole expression that turns out to be 28.2904. For those people who actually want to implement this on Octave or MATLAB, they can do it in. I'm giving you like a time of 2 minutes. Meanwhile, just excuse me for a minute. I'll be back in a minute. Okay. You can actually implement this. Meanwhile, you can implement this thing. I'll be back in a. Okay, I'm back here. Uh, let's resume. I'm sure you can hear my voice, right? I'm audible.
Yes, we can.
Okay, sure. Thank you. Then here are some other examples. Here we are finding the value for the this particular value pi by 4 using this sine function. So we want to find the value for the sine pi by 4. So for those people who were actually FSC background, they know because I remember that we used to remember all these values because we didn't have the calculators available in the examination. So sine pi by 4 would return me the value 0.707. Okay, similarly, the value for the exponential 10, that is e power 10, is since e is 2 point something something value, so e power 10 would return me some value that is actually very large. Okay, so it will return me the value for e power 10. Again, this is very important because log of 142 is not exactly the log of 10 142. So if you want to calculate, even if in fact some people have the scientific calculators and they want to find the value of log 10. So when they do it, 142, it will return the value 2.15. That is not exactly the value that MATLAB is returning. Okay, the MATLAB is returning the value 4.95, but we got the result. If you do this computation on scientific calculator, that was 2.1522. Okay, so what happens here is that again this shows me the result for the natural log, and this shows me the result for the common log. Okay, so in order to find the value for the common log, you have to use log 10 and then the expression or the variable. So again, for if you do the ln of ln of 142 on your scientific calculators, it will return you the same value, that is 4.9558. Okay, so that was important. I thought this could be a major difference, because the two values are actually quite different from each other. So you might know about this thing. Okay, this was it for the mathematical computation. Since I have already mentioned here, I have already mentioned the most of the mathematical or the simple mathematical functions that we use in MATLAB. So you can go and test these commands, practice on these commands or these functions. Okay, one other thing, other thing that I actually forgot is the help EL fun and the help spec fun. These two functions or these two commands return you the list of all the MATLAB mathematical functions. So, for example, if I do this help EL fun, it returns me the it returns me all these particular functions that I actually explained there, that I've mentioned in that table. In fact, here a lot of other functions are also given, but you can actually implement these functions on your own since you know the help command or directory where you can actually find these functions and you can go and test these functions on your own. So I guess that was it for the mathematical functions. You got the idea how how are we using these mathematical functions in MATLAB and how can we actually give them a simple variable as an input and they return us the value for that input value. Okay, so now comes the very major or very important feature of MATLAB. I guess there is a question, right?
Yes, sir, there is a question.
Okay.
A student is asking that, say I have a constant A. So I want to
Mhm.
solve the equation and want the answer in terms of A. What I have to do?
Okay, so what I'm getting from the question is that you have a variable a, and let's say I assign it a value 10, okay? And you want that I want to do some expression on this variable, and I want the result back. I want to get the result again in the variable a, right? If I got your question right. So what you have to do is you have to place this variable again on the left hand side of the assignment operator, and here you can perform whatever function you want to do. For example, I want to do 5 into a, let's say. So what happens here is you had a memory. uh, I don't know if I can remove this extra junk. Yeah. So what happens here is that you have a memory located for the variable a in your heap. Okay. So here is your memory. Here you assign the variable. Here you assign the value 10 to this particular variable. Now what happens is you have performed this operation, that is a into 5. This will return you the value 50, right? And you want to save this value 50 into the same command or into the same variable as you previously used. So for that reason, you can actually use the assignment operator and you would override the value of a by the same expression a into 5. I hope I could answer your question. So okay, yeah. Coming back to the MATLAB capabilities to plot basic things. So again, the MATLAB has an excellent set of graphic tools. Okay, you can actually you can uh, show or you can display multiple images at one time using the MATLAB command subplot. Okay, in fact, you can also show multiple images in the way you want them to be. You want them to look. For example, if you want three images in the upper row and three images in the lower row, that means that you will make a matrix kind of thing with with two rows and three columns. So in that particular sense, you are getting three images in the first row and three images in the second row. So you can simply do this using the command subplot of the MATLAB. So it has an excellent set of graphic tools. So you don't really have to worry about things when you will be plotting the plotting the images, displaying the images, plotting some complex mathematical functions or even the simpler functions. Okay. Again, you are highly encouraged to plot mathematical functions and results of analysis as often as possible because MATLAB is giving you something really good. So you should use that particular capability of MATLAB in order to look at the data set. For example, those people who will be working later in the fields of AI or machine learning or deep learning, they know that the value of uh, looking at the data set. If you know what a data set actually looks like, you can actually solve many of the problems. Okay, for example, I can quote one example from the work I was doing in the last week, that the data was actually in the 8-bit depth format. You might know what 8-bit depth format actually is, so don't worry about it. But I needed the data to be in the 1 bit depth format. Okay, and I didn't know what I trained the whole model. I trained the model, and I was getting the wrong results. Obviously, because the data was not exactly in the same format as I wanted them to be, as I wanted it to be. So then I discussed this error with my supervisor, and he said that plot the data. I plotted that data as array as the same matrices as I explained earlier. Uh, that was basically the images. So I plotted those images as matrices, and I was able to know that those images were not exactly the format that I wanted them to be. Okay, so plotting the things could actually help you and could solve many of the errors, and they can save you from like efforts of months. For example, if you are working on a machine learning problem and you have gathered data by spending like weeks or months on some particular problem, and the results are you are not getting the desired results just because the let's say the data was in some other format, and you think that, oh, my whole data was not labeled correctly and my whole data was corrupt, and you do the whole process again, and it will consume again 3 or 4 months of yours. Okay, so it's important to know what your data actually looks like, and for that purpose use the plotting commands of the MATLAB. Okay. Then again, trying to understand mathematical equations with graphics is an enjoyable and very efficient way of learning mathematics. Obviously, when you are actually seeing things happen, it becomes fun for you and you enjoy things. And being able to plot mathematical functions and data freely is the most important step in the in almost every field. Not actually in deep learning or machine learning, but in every field, it's important that you know what your data actually looks like. Okay, that is the power for that is actually the significance of plotting the in MATLAB.
Okay, sir, the student which asked previously question. So he said, my
Mhm.
question is not answered actually. I want you to know if MATLAB can provide me an analytical solution of equations. Like if you want to know the derivative of y is equal to sine x, can MATLAB give me cos of x?
Okay, we can discuss this question at the end. I guess we can complete these slides. We got some. We will get some time at the end, so we can discuss it maybe one to one.
Yes, sir. Okay.
Okay, sure. Thank you. Uh, because I want to show you these plotting techniques because these are important, and we can discuss your question later. Okay, in order to create simple plots here in MATLAB, what you have to do is you have to define a vector first. Okay, so for example, here I have defined a vector. Now, what a vector is, it's a simple matrix, but it could be a simple row matrix or a column matrix. So a simple matrix which only has one row or it has one column, that is called a vector. So for this reason, I have to define the vector for the x coordinates of the I have defined the vector for the x coordinates. Then I have to do the same for the y coordinates. These are now basically the solutions for the x values. Okay, so we can say that there was some particular function that was applied. Let's say y was equals to I'm not sure here what the function exactly is, but let's say y was in fact equals to 3 into x. So what happens here is that it multiplies each value of x to this particular function and then returns me the value in y. So here we are not bothered with the whatever the function was. We are only bothered with what exactly the values of y's were for the particular values of x. So here, let me clean this and show you again. What happens is, if I try to plot this particular vector, that is x, which denotes the x coordinates, and y, which denotes the y coordinates, and I will be using the simple MATLAB command plot in order to plot these, and I'll be getting something like this. Okay, so what's happening here is that the MATLAB defined the x coordinates as exactly as the values that were defined for the x coordinate vector. Okay, and how does the MATLAB know that it's for the x coordinates? By placing it in the first argument. Okay, so the first argument in the plot function is the x coordinates. Okay, and the second, the y coordinates, or the I'll be placing the y coordinates in the second place for the plot function. So what's happening here is that I'm getting the value for the value x is equals to 1. I'm getting the answer 3. So what MATLAB does is it goes to position 1, x is equals to 1, and it gives assigns the value y is equals to 3 for that particular location. Similarly, for 2 it's -1, for 3 it's 2, for 4 it's again 4, and for 5 it's 5, and for 6 it's again 1. So once the MATLAB has defined, or MATLAB has actually defined the points for each, the corresponding points, has plotted the corresponding points. Next step is to join all the points. So sorry, the MATLAB has actually joined all the points. Now, one major thing is that the size of this particular vector x and the size of this particular vector y must always be equal. Okay, so whenever you will try to plot something with these two vectors, or in fact, whenever you will be plotting anything in MATLAB using this plot command, the size of the two vectors must always or should always be equal. So, for example, if I show you some example that what if the sizes are not equal, it will not run. Okay, so if a is equals to, let's say, 1 2 3, and b is equals to 2 and 3, and I want to plot the values for a and b, it will return me the error. Okay, and the vectors, the error is vectors must be of the same length. So it's very important that these two vectors must always be of the same length. Okay, whatever goes in the plot function, that doesn't require to be exactly these two vectors, but whatever goes in the arguments of plot function, those two expressions must always be equal in length. Okay, wrapping things up, we can actually save some time for the question and answers. Just let me give me 10 more minutes. Okay, again, this is a simple command. Now here, the x coordinates or the x-axis is different from the x coordinates of the previous problem. Here the x coordinates were defined like 1 2 3 4 and 5 and 6, but here the x coordinates are actually defined in terms of some expression. So what this expression does is, it is basically a range. So the range is from 0 to 2 pi. Now 2 pi must be 6 point something value, because pi is 3.14, so 2 pi must be 6.26 or something like that, 6.28, or the value could be something like that. So I have defined a range from 0 to 2 pi, and then what the middle thing does is it is defining the step size. Okay, so pi by 100, when you define the pi by 100, it will return you some value of like 0.03 or something like this. So what happens is, it will go from 0 to, the MATLAB will go from 0 to 2 pi in steps of pi by 100. So this could also be set as the stepping size for this particular command. And if you don't mention this command, if you don't mention this number in between the two ranges, then the MATLAB will assign a default value of 1. That is, the step size would be 1 if you don't define the particular value here as the step size. Okay, so I have defined the value for the x. uh, MATLAB will perform the operation of sine of x for on each value of x, and then we'll assign the those results to the variable y, and then we will plot the variable x and y, and we get this very beautiful sine wave. Okay, you can see that the sine wave starts at 0 as mentioned here, and it goes up to 6.2 or something like this value. Okay, so let's call it 6.2. So it goes from 0 to 6.2 and in steps of pi by 100. Okay, so that was it in this particular example. uh, Again, you can also, obviously this plot doesn't define anything. This plot, I don't know what this function is. If I don't know what a sine function is or sine wave, what a sine wave looks like, then I don't know what this particular function is doing or the plot is doing. So I have to do what I have to do is add some title or the legends or the uh, assign some names to the axis. So you have to define the axis labels, and you have to define the title. So in order to do that, you can actually use the MATLAB commands of x label. This will assign an x label uh, to this particular x coordinate, and it says that x is equals to 0 to 2 pi. Okay, so it has defined it has basically assigned or show displayed the x label. Similarly, there comes the y label, and then comes the title of the whole this particular graph. Okay, the title is plot of the sine function. This one is the difficult of all. Uh, this example is the difficult of all. So what happens here is that you are actually, okay, there is this third graph that is not visible because of this its color, but there are three graphs mentioned here. Okay, now it's visible. Okay, this the red curve here is the third graph mentioned. Let's say denoted by this. Okay, what's happening here is that we have defined the x coordinates. Again, it's 100 to 0 to 2 pi in the steps of 100 by pi by 100. Then y1. So what is y1 here? So the y1 is denoted here using this legend, and it shows that the particular graph with this dotted lines is the 2 into cos of x, and that is actually the y of 1. So we needed something in order to express our graphs. If we are actually plotting multiple data sets of multiple plots in this single window, then we needed something in order to differentiate between these particular data sets. So in order to do that, we use this particular command, that is legend. So you will also be working with these legend with this legend command later when you will be working uh, with your own data sets. So it's a very useful command actually. Then comes the title. Again, you know about the title. X label, you know about the x label, you know about the y label. Okay, what are these things? What are these things? We only knew that in the plot function, we passed like x values, and we passed like y values, and now there are like 6 to 7 or 8 values here. So there is a problem. So these values or these particular notations define the shape of your curve. Okay, for example, this particular notation or this particular symbol shows that your graph would actually be dotted line. Okay, this line shows that your graph would be a straight line, as you can see here by number 2. Okay, let me cross it. Okay, this was graph 1, this was graph 2, and this is graph 3, and it's denoted by colon, which is a dotted line, again a dotted line. Okay, so here are some specifying. These are actually specifying. 3 minutes. Let me wrap up things. You can see that in order to define the color of the curve, you can use these symbols. In order to define the style of your curve, you can actually use these symbols. I could share these slides with you, and you can share see it later. Else, you can also look at the help on the internet. Then comes the matrices. You already know about the matrices. I have mentioned that matrices here, if it only has one row, so it is a vector. And here, what I'm doing here is that I'm taking the transpose of this row vector. So column vector. W was a column vector. I have taken the transpose of this column vector using this particular command by placing a steric mark over it, and now it's kind of a row vector. I don't know, maybe for this particular case that the v, sorry, my bad, the v was a row vector. I took transpose of it, and now it's a column vector. Okay, sorry for the previous mistake. Again, if I want to print only, or if I want to extract only the values 1 from 3 of this particular row vector, then that is these three values, then I can simply index them. That is v of 1 up to 3. Okay, this is simple indexing. And if I want values of this particular row vector v from third value to up to the end, what I can define is I can say v into 3 up to the end. So it has returned me the last three values, or it has returned me the values from third index to the last index for the vector v. Similarly, 1 to end will also return me the values, or it will return me the whole row, because 1 to end means that it returning me the value 1 to the end. I'm sure these are pretty basic concepts, so you don't really have to worry about them. Again, if you want to define a matrix, 3 by 3 matrix in the MATLAB, you can actually use this command. So here, in order to differentiate between columns, you use the semicolon. Okay, so I have defined sorry, the rows. So I have defined the first row. Then in order to go to the second row, in order to define the second row, I'll be separating these two rows by a semicolon. Similarly, I'm separating these two, the row number 2 and the row number 3, using this semicolon. Okay, this is again, it's simple stuff. uh, okay, these are some particular functions that you could actually use in order to find the size of a matrix. So you just have to input the matrix in the size function. It will return you the size. Okay, the last thing that I want you to know is the script files. Okay. Okay. What the script file does is exactly the same coding that we did in the command window, but here we have the leverage or the freedom in order to write freely. Okay, so I can write freely whatever I want to write, and then in the end, I have what I can do is I have implemented all the expressions, I have defined all the variables, I have defined everything, I have plotted the variables, but nothing is working unless until you press the run command. So whenever you will press the run command, only then the MATLAB will execute all these commands, and it's very similar to the other programming languages such as C and C++. So it's again the same plot. I have used the same code in order to show this particular example. In order to create a simple text file, you just have to go to new script, and that's it. And control S in order to save your text file somewhere in the parent directory. You don't have to worry about the parent directory if you are working just in the parent directory. But if you want to change the directory, then you have to change the directory here also in the MATLAB directory line, or whatever this is. Okay, so I guess you got the idea of text files, or sorry, the script files. These are also called the M files, and it always ends with the .m format. Another thing, that is a function. How do you define a function in MATLAB? So for that reason, this is a basic syntax that you have to follow in order to define the functions. it's not as simple as the C++ or the Python, but you have to define a new script file with the function. You have to write function keyword, then the name of the function, the assignment operator, sorry, the return value, the name of the function, and the input value. Okay, so in order to define the function, you will create a new text file. You will use the keyword function, the return value, the name of the function, and then the input, and you do the computation here, and I'm returning the value for the this particular f here. So there is no return command as we use in the C or C++ that we would have been using the return f command there in C, but in order to return something here, whatever the value that was stored for this particular variable f, that would be returned to the parent directory. Okay, and here I'm calling the function factorial of 5. It will go here. It calls the function, it takes the input, does the computation, returns me the value of f. Here I get the value of f, and here is the answer. So I guess that's it from my side, and our time is almost over too. So I would conclude by saying that MATLAB can behave as a simple and a complex calculator. You can actually compute anything on MATLAB. It's nice. It does not only does the calculations, but it also does the plotting very nicely for you, and it's really relatively easier to learn. And that's it from my side. So any question from you guys is welcome.
Okay, so Talha, there was one question. Someone was asking if you could highlight any courses online or any YouTube channel that you tell people to learn from other than the workshop.
Yeah, I actually got your question, but I'm sorry, I don't really know exactly about the online courses right now because again, I didn't prepare for the for the online courses, but I can actually recommend you some of the online courses via this platform. So I will communicate with the moderators, and they can they can actually share the resources on Facebook page or via the email. Okay.
Sure, that would be amazing.
Okay. Thank you.
Okay, guys, any other question you guys want to ask? Please type in the chat. If not, then shortly we'll be sharing a feedback form, a link. Please fill that, and on the basis of that, you guys will be receiving your what do you say, your certificate of attending this the workshop. So, any questions?
अच्छा एंड गाइस आपको आपको ईमेल में आपके साथ शेयर हो जाएगा we'll share the presentation and the recording of this entire lecture with you as well, so don't worry about that. And we're just going to share the link in just a few minutes.
The feedback form link has been shared, and I want to say thank you to Talha for your time, for your expertise.
No problem. It was actually a pleasure for me to be here. Thank you so much for inviting me. It was fun actually. Thank you.
We
अच्छा
hope to see you again as well.
Ahmed Raza, can you please repeat your question once more?
Okay, so I believe that by an analytical solution, there are basically two types of solution, if I'm not wrong, the numerical solution and the analytical solution. So MATLAB would provide you the numerical solution, but if you want the MATLAB to do the computation, to solve the equations for you, taking the variables from left hand side to the right hand side and doing those dirty work we do on the do on the pages, that then I'm afraid MATLAB won't be doing that for you. MATLAB would only provide you the numerical solution for a particular example. For instance, if you want to find the eigenvalues or eigenvectors for a particular problem, okay. So in order to find the eigenvalues or eigenvectors, the procedure is very lengthy. You will learn in the linear algebra course. But there is a simple command svd in MATLAB in order to find the eigenvalues and eigenvectors. It will return you the eigenvalues and eigenvectors in like milliseconds. So I don't think so. The MATLAB provides you the complete solution, the analytical solution, if I'm guessing it right, the analytical solution to the equations, but it will return you the numerical solution, and then you can actually reverse engineer those answers uh, in order to find the analytical solution. You can actually perform the steps by steps, and since you know the numerical answer of that particular equation, so you can since you know the numerical solution, so you can actually find or reverse engineer the analytical solution. So I hope that I could actually answer your question.
So guys, I believe there are no more questions now. So let's, okay, what kind of project can we do with MATLAB? Last question, Talha.
Okay, so what can uh, I actually presented a slide initially in the presentation. I can share it again. So let me share it again.
If it is in the
So
slide,
whatever comes under these things, yeah, just give me 30 seconds. I can explain it to them. Okay, whatever comes under these headings, deep learning, image processing, computer vision, whatever projects come under these headings, you can do it on MATLAB. Okay, for example, in computer vision, you can find the edge detection. You can do the edge detection. In deep learning, you can find the faces of someone. You can perform the YOLO extraction. You can do classification tasks. In control system, you can find the state space representation. In digital signal processing, you can perform the communication. So a lot of things, a lot of projects you can actually do in MATLAB. So if you could look at on if you could look on these particular fields that I mentioned, you can find multiple projects that you can actually work on.
And to the person who asked अगर हम if we're going to be arranging more complex and higher level workshops for MATLAB, that actually depends on the instructors. If Talha Mehboob, who has blessed us with his presence over here, will bless us again, so yes, we will definitely arrange more MATLAB sessions for you guys. तो आपको अब I think since it's 10 p.m. अब form जो है, the form will be accepting responses. तो उसमें प्लीज़ गिव योर फीडबैक, ठीक है, और उसमें सजेशंस भी, योर सजेशंस विल बी वेरी मच अप्रिशिएटेड एज वेल. एंड अगर आप लोगों ने अपडेटेड रहना है फॉर आर अपकमिंग इवेंट्स, अपकमिंग वर्कशॉप्स, आई थिंक द टेक टॉक की जो सीरीज़ है, दिस विल कीप ऑन गोइंग for quite some time. So do follow IEEE Seeks and NAS Cybersecurity Club on social media. ऊपर लिंक्स भी दी हुई हैं, एंड आई थिंक आपको हम ईमेल में भी आपको लिंक्स भेज देंगे दोनों सोसाइटीज़ के सारे प्लेटफॉर्म्स की. तो इफ़ देयर आर एनी मोर क्वेश्चंस